In this project, I'm building a mini radar scanner using an Arduino, a servo motor, and an ultrasonic sensor. The servo sweeps the sensor back and forth, while the ultrasonic sensor measures how far away objects are, kind of like a simple radar system. Because I don't have a 3D printer, I'll be instead using everyday materials to attach the ultrasonic sensor to the servo motor, which you will see. So first we got the Arduino, and of course the cable. Next we have the ultrasonic sensor, and then the servo. Of course, we gotta have the horns, gotta attach the ultrasonic sensor, breadboard, and of course we have to have wires. So first I'm wiring the servo. I first connected the power. However, I'm gonna change this soon. Now I'm connecting the pins. Here's the ultrasonic sensor. For this one I have to use male female because I can see one of them you have to use a female. Here I connected the power to the breadboard so I can connect more ports to the power. This is because the ultrasonic sensor also needs the power, so if I connect to the breadboard it can share the power through the rails. Now I'm connecting the ground, same principle. I need to connect the ground to the ultrasonic sensor as well as the servo. Now I'm connecting the trig pins and also the echo pins, so I can use them in the Arduino code. The physical build was honestly really simple. This is a couple of wires, nothing too complicated, but the code is kind of more difficult in my opinion. So first we have to include servo H. This is to control the servo. So we put servo, radar, servo. This allows us to control the servo. Now we do the pin connections. This is pretty standard for every single project. So we do const int integer servo pin equals 9. That's what I said on mine. If you guys were to do this project yourself, you might have different numbers. It just depends what you connected into the Arduino. So these are the pins for the ultrasonic sensor. So what I want to do first is I want to create a maximum distance, and this will be in centimeters because the ultrasonic sensors, everything is in centimeters. So we're going to put max d equals 100, and don't forget the semicolons of course. So here's the actual stuff. We first have to do the void setup, which is basically what it runs before it goes through the loop. So first, of course, we have to use serial begin because we want to use a serial monitor. So we do 9600. Next we do radar servo dot attach and the servo pin, which we defined up here, which was 9. Then we do pin mode, which will activate these pins, output and input. We want to print something into the serial monitor so we know it's starting. So let's do println and let's do radar starting. So for this project I wanted it to sweep from 0 degrees to 180 degrees. So for this we have to create a for loop. So do for int angle equals 0. Angle is less than or equal to 180, and then we have to add angle, so it's going to increment. Now I want to get the distance, so we do int distance, so it's an integer, and then we get the distance like this. Now what we want to do is we want to print the radar data, so we do print radar data. Now I want to create a second one, so then it sweeps from 180 to 0. The first one, as you can see, it goes from 0 to 180 and then it increments. Now what I want to do is basically do the opposite. So we're going to start from 180. So you're probably wondering, what is get distance anyways? So I actually haven't defined it yet. So we're going to define the function right here. Trig pin low. Now next we want to send a 10 microsecond pulse. So what we do is we do a digital write again. Then we're going to delay the microseconds, and then we're going to turn it off. Because we're going to store a lot of data points for the duration, we're going to do a long duration. So we're going to do equals pulse in. This time we're going to do echo pin. So if duration, we return the max distance. And max d, I think is what I defined it right there. So now what we have to do is we have to convert the time into distance. Speed equals distance over time. Then we gotta create this, basically saying that if the distance is greater than the max distance, then the distance literally just becomes max distance. Also, I forgot to explain why we divided by 2. So it goes from the sensor to the object and then back to the sensor. We just want the distance from the sensor to the object, but since it goes from the sensor to the object back to the sensor, it like overcounts it, so we have to divide everything by 2. And the 0.034 speed of sound, centimeters per microsecond. Now this is all cool, but we want to see what's happening. We want to print the radar data. And we're pretty much done. So now I'm testing out the servo. As you can see, it's going back and forth, which works. I just need to go 180 degrees. Now I'm basically attaching it to my notebook. And I was really scuffed because I don't have like the right materials and it wasn't very stable. As you can see, I ended up taping the ultrasonic sensor to an eraser. And I attached the horn to the eraser too, so everything connects well. As you can see, I attached everything. Took a really long time because, you know, it's not very stable. Hopefully when I get a 3D printer, it will be much easier. Now let's test it out. If I put something right in front of it, the number changes. And if I take it away, as you can see, the second number increases and also the first number. The second number basically is the angle, and then the first number is the distance. So if I put something closer, instantly it decreases, as you can see. So that actually wraps it up. Here's a cute cat video.